So the final video is where we're going to look at doing an aldol reaction using a Ziemmerman Traxler transition state. So this is actually quite advanced and model kits can really help in this case. So in this reaction, we take this ketone, we treat it with LDA at -78 degrees to make the enolate. In this case, it's this enolate here, and then we add the aldehyde that we want. And as you should know from your lecture notes, we go through a 6-member transition state. So this is a 6-member transition state where you have your lithium in the middle chelating or holding both partners together. And this is what I've tried to represent here using this model kit. So again, we have the lithium in the middle. Apologies for the colour, it's purple. There's the oxygen, there's the pH, there's your C double bond C, and note the methyl group is on the opposite side to the benzene ring. There's your H. And then on the other side, we have, this is the aldehyde. So here's the aldehyde, there's the proton of the aldehyde, and there's the ethyl chain. And you can see it's freely rotating. Now, with this question, we need to put it into the Ziemmerman Traxler transition state. So you need to bear with me on this because it does get a little bit complicated. So let's deal with the phenyl substituent first. So at the back, we have the lithium at the top left, which is where I'm just going to put it. And then that goes down to an oxygen. And then we have the phenyl group like this, which is up. So it's going up according to this diagram here. Then going down, we have the methyl, which is dead opposite. And then there's the hydrogen. So we've sort of dealt with that area of the Ziemmerman Traxler. Going to the other side, this lithium is coordinating to this oxygen, on the aldehyde. And then on the aldehyde, you'll know that the H needs to go axial, if it's going to play ball. And then the ethyl chain needs to come equatorial as much as possible. So we've kind of got it held in this kind of conformation here. And if you can draw that in flat, that's absolutely great. Now the hard part, I think, is going from this flat bit where you've made your bonds to redrawing it again out in a chain. So if we just, I'm just going to have made and broken some bonds at the same time, and now I'm using different types of bond in between, so it's not ideal. But effectively, that pH group was up, and this is now remade the C double bond C like this. So I'm going to have to do a bit of a switch about with all of my bonds to steal a bond from somewhere else. So we end up with this. So this is going to make a ketone. This is where you need to have numerous hands. So that has now become a C double bond C. This H is that H here, or in this structure, this H here. That methyl group is that methyl group down. And then we've got our aldehyde where the H is up, the ethyl group is equatorial, and there's my oxygen, carbon to oxygen bond, and this is the lithium salt, which will be substituted for proton on workup. So then what we need to do is get it so it's flat again. So I want to get to a structure that looks like this. So all you do is you pick it up and you move it. So if we do it like that, benzene ring, carbonyl, and then as we go along, we can see if we make it so it's into a zigzag chain, the methyl group is going back, the hydrogen's coming forward, and then going along further. This will become the OH, so the OH is going back, the hydrogen's coming forward, and there's the remainder of your ethyl chain. I admit it's not necessarily completely clear using this, but I think the key part when doing a Ziemmerman Traxler using model kits is perhaps just making this kind of 6-membered ring intermediate, and then you can at least work from there.